So we looked at adding labels, adding titles to our graphs. Good thing to do if we want to save them, we want to put them in a paper, we want to hang on to them and look at them later on. But we started this discussion by saying we also wanted to use the plotting or graphing as a way of thinking about different kinds of results. We started that when we began plotting different functions in different windows. But even there, what I showed you earlier could have been a bit misleading because it looked like the linear graph and the exponential graph grew at different levels, but we didn't have a clear sense of that because we didn't change the scales. The scale on the y-axis for the linear graph only went up to 30. The scale on the y-axis for the exponential graph went up to 140,000. And we'd like to be able to better visualize differences. So, if the scales are different on the graphs, how could we deal with that? One option is to explicitly set limits on the axis. Right now, we're just letting PyLab do that automatically. It figures out what's the maximum range of y values, and it sets the axis scale appropriately. We could control it. A second option is to actually plot multiple functions on the same display, but to choose which ones I want to display. We did this earlier when we put all four together, and we saw that that wasn't really effective because the smallest ones were too small. But we're going to look at how we might do a different way of doing that multiple display to get a better sense of that kind of difference in scale. So let's look at both of these. Changing limits on the axes. Here's the code, things we've been using as before. Notice again, I'm going to get into that habit of just clearing the frame before I deal with it. And now I can explicitly say, I want to have the y limit go from 0 to 1,000. I'm picking that number because I happen to know what this display is going to look like. Some experimentation might let you decide an appropriate set. But what you should see here is that when I am plotting, I have the ability to explicitly set the range on the y-axis. By the way, I could set the same thing on the x-axis. And I don't have to show all of the values of the y function or the x function. I could actually pull out just a subset of it. So in this case, I'm going to do a plot for the linear. I'm going to do a plot for the quadratic, each in their own frame. But I'm going to set the y limit to be the same in both frames, and then I label them. And let's look at what happens when we do that. This is actually quite nice. And why is it nice? Because now I can see what's the difference between a linear function and a quadratic function. We knew that the quadratic would grow more rapidly, but now we get a sense of that difference because I've set it up so that both y-axes have the same range. Notice also I picked a value that has a little bit of a gap up here. I happen to know that the y values are going to go up to about 800. I could have lowered it down, but this was a nice way of picking a range that was going to let me see that difference. From the perspective of visualizing data, this is nice because now I can really compare how quickly does quadratic grow relative to linear while still seeing the difference. What else might I do? Well, I could overlay the plots on top of one another, but do it in a way where I actually pick which ones I want to think about. We saw earlier that trying to compare linear against exponential is going to be a wash because you'll never see the linear. But now I can go back to the idea of set up a function or a frame, clear it, and then in this case, let's plot two functions inside of that frame, pick a second one, clear it, and plot another two functions inside of that frame. And if I do that, again, because I am calling both of those plots inside of the same figure, they're going to overlay. And because I'm calling the second pair of plots inside the same frame, they're going to get an overlay. But I have a better way of doing the comparison. And when I do that, I get the following display. Now I can see the difference between linear and quadratic, and I can see the difference between cubic and exponential. And interestingly, you may not have realized that, cubic early on actually grows a little bit faster than exponential, but after some point, exponential takes off and really overwhelms it. Notice at the same time, I should be careful about comparing these two graphs because this one only goes up to 900, that one goes up to 140,000. Part of the message for you here, if I want to compare things, I need to think about what I'm comparing, but it gives me a way of actually doing that visualization in a very nice way. So there are some times when I want to overlay things on the same window, and other times when I want to just have them displayed side by side. I can do a couple of other things here. Now that I'm starting to do other displays on top of things, I could also add a legend that helps me tell which plot is which. If I go back to this window, you kind of know which one's quadratic, which one's linear, but it'd be handy to label them. And I can do that. In particular, I can add in a label for a plot. Here I'm using the keyword label, and then the equal sign, and then the specific label to put on each one of them. And I'm putting obvious labels here. I'm going to label each one of these plots so that now when I display them, I'm going to get a nice display out. One more thing before I do them. I need to decide where am I going to put the legend. And I could actually give it a location by giving under the plot function legend the keyword for location of upper left. Or I could simply say put the legend up, but give it no argument and let Pylab decide what it thinks is the best location to use. Notice, by the way, that I need to do this because it's not just that I've put the label here. I actually have to command Pylab to put a legend in for it to appear. Okay, with that in mind, what does it look like? Yeah, kind of cool. Remember, I said use the upper left location. There's the legend. And now each graph has a legend associated with it. So I know that the blue line, this one down here, is linear, and the green line is quadratic. When I let Pylab decide where to place it, it makes a decision that it thinks is the best location to put it. You might argue that in this case, putting it in the upper right corner really isn't great because it overlaps a little bit of the graph. It might have been better to put it over there, but we leave it up to Pylab to decide where to place it. And again, now I know that this is the cubic and that is the exponential because the legend tells me that right there. So that's great. I can start adding more information to the plots that I'm using.